Alright everyone, hope you can hear me fine. Today we're going to build the cheapest oscilloscope possible. I got this is a DSO138mini. It is said to be the improved version of the DSO138, and I think this is an open source scope. I'm not sure how good it is, and it's like what, 20 or 15 bucks, so it's super cheap. Anyway, I got this on AliExpress. This is the case. Hopefully tonight we can finish building this. Now I've actually opened this already because when I got it I was so excited to see like what the quality is like, and it's actually not so bad, but I'm just gonna do it again, open it again for you guys. Alright, cool. So QC passed. What type of QC? Anyway. So components just scatter all over. No big deal. Put this here. Let's see. There's one more thing in here. What's this? User manual. Okay, let's see. Tools you need before you start, notes, blah blah blah. Okay, let's see what it says here. Step 2. What's step 1? Just read this thing here. Alright, anyway. So it says a note, always meter resistor values before soldering because color bands are easy to misread. Okay, so I got my my multimeter here. It is a Fluke 17B plus. I think this model is only available in China or something. I got this back in Taiwan for super cheap, and yeah, it's a good scope. I mean, not scope, this is a multimeter. Anyway, let's take a look at this thing. What is this? Attention, do not remove the sticker on J1 pads if BNC connector is to be installed. This is to avoid possible short. Okay, let's just put this aside. So there's just 2 boards, simple enough. Okay, let's take a look. So there are these prototyping holes. I'm not sure what they're used for. Oh, maybe there's like third-party mods or something. But everything we have to solder is through hole. Oh, I think it's only one-sided too. So through hole all the one side, which is pretty cool. Let's see this thing here. So this is probably the other most common LCD display, the LDO something, I forgot what the model number is. And it looks like it uses the STM32C8T6 chip. I know, like, the oscilloscope was one of the demo, on one of their dev board with this chip or these series of chips. So maybe they just took the design and, you know, bundle it in a good form factor and call it open source. But anyway, all these surface mounts are soldered on for us, so we don't have to worry about any of that. DSO138mini by JYE Tech. Alright, anyway, cool. So, alright, let's see. So, first thing they want us to do, this is kind of funny. So, R1 and R13s are 100K, R2 1.8 mega. So, I guess we just solder them on, no matter what. I guess it'll be good if we first maybe sort them, since I'm kind of bad at reading the resistor bands. I mean, I'm bad at reading it in English. Let's see what this bag contains. These are one of those test clips. These are probably for, you know, your makeshift probe. So this thing like sticks out like that. There's a hook over here. Not sure you can see that. So you just hook to your, you know, whatever signal you want like this. So you hook it up and it just conducts the electricity. And back here, you can open it and then you can solder a wire to this contact. And that acts like a makeshift probe or a cheap ass probe. We have these headers, some push buttons, a switch of some kind, some variable. I don't know what this is, variable something. Let's just all dump it out. I feel like I'm gonna lose these during the course of some time. Hang on a sec, let me adjust something. Alright. So this is the BNC it's talking about. Oh, so like this connector comes here, like this. So there's a tape over here, which masks these two pads. I guess like you can use just solder your wires or whatever probe you want over at these two pins. But if you want to use this, since you don't want to short these two pins, they thoughtfully put this tape over, so you know you don't short when you mount this BNC connector thingy. I'm not sure if I want to use this yet because I'm using this for like an audio application. So maybe I'm not even going to get a proper probe. We'll see. More cables. Oh, let's see. Oh, jeez, this is quite a mess. Let's try to sort these out. Some switch, like a 3-position switch. We got 3 of these straight up like that. Let's put this here. Like side switch. My guess this is the on-off switch. Some connectors, JST connectors. Put this here. 2 of these variable stuff. Buttons, all the mechanical stuff goes that corner. All these headers are mechanical. Capacitors over here. Headers. More headers. No, I just want to separate the components a bit here because it can get really messy. And then we'll measure out what resistor values are those. This is a blue LED. I don't like this blue LED, it looks weird. I might want to change that later. But anyway, let's continue. A diode. My guess is these green thing. My guess this is the, what's that called? A coil? I don't know what. Yeah, it's a coil, right? Like they measure in Henry. No, the other partner of the capacitor. I forgot. I just have lost it in my mind. Anyway, some capacitors here. Okay, so these are all the resistors we have. All right. I guess we'll just start with, I don't know. It says to start with resistors. We have what, so many resistors. Let's just go by the value so we don't have to like measure twice. So I guess that would be R1 and R13, which is 100K. And oh my god, these are so hard to read. And because I don't really have a lighting. So anyway, we're just gonna use my scope. I mean, shoot, not scope. My multimeter to measure it. If you guys can see that. Okay, that's really bad, but it has a backlight. All right, let's see this. So it's on the ohm mode. What's this? This is 1K. All right. 1K. I'm not sure if we want to label this or what. 1K. I'm reading the instructions on the other side. I guess this might be 1.1K because there's no 1K. Yeah, 1.09. That's 1K, 1.1. So apparently there is 3 of these. I'm going to put this over there. What is this? This is 100K. So yeah, this is what we want, R1 or R13, which I'm gonna place it here. Hope it doesn't roll away. I know this is not the best surface. I'm just being cheap and use a big envelope. What is this? Oh, you guys can read that. Let's see. This is 180 ohm, I guess. Yeah, so this is R7 and 11. I'm not gonna remember where I put those when I'm done with this, but we're just focused on finding R1 and R13 right now. This is 120. 120. Let's put that there. What's this? 180 or something. Okay, maybe I'm shorting with my own body. Oh, come on. Okay, this is 200K, I guess. 200K. There's only one. Oh, there's two 200Ks. I just want to find R1 and R13, or maybe we should just measure this and see where this goes, and then cross out whatever. Yeah, maybe that's a better approach. This is 1.1K. See, I already forgot where 1.1K is, probably here. But I want to find. So what is this color code on this one? It's not really easy to read because these resistors are like blue, and if you paint over blue, obviously you're not gonna see what the true paint color is. This is 180 ohm. Gosh, I just want to find that right one. Yeah, this approach doesn't work. We'll just go back to this guy when we would whatever pick up whatever register. So I guess we'll start with this one. Gonna measure another time, one more time, just to make sure. Yep, this is 100K. So let's find R1 over here. Wait, we better see what's on the other side of this thing. Okay, so not a lot apparently. Ooh, look at how the finished thing. Interesting. Or I calibrate. Not a lot to actually study on, I guess. Anyway, let's just start finding R1. Where is R1? D1. Or we could put R13 in that case. Oh, R1's over here. So this one's R1, right? I already forgot. 100K. That is correct. So it goes into that hole over there. I'm just going to eyeball this, fold it. There are things that will help you folding it at the right length of this through hole, but come on, I don't bother. It's not going to affect the outcome of what you're doing. All right, so I got my iron heated already. I I changed back to the bigger tip I had, because I know, well, we're not gonna do some super tiny SMD soldering. So let's see, this one fairly simple. Let's just do this. Every build, I think this build will be pretty simple and easy. All right, 2 holes down, that holds it together, great. Well, I'm gonna cut this later. Well, the bad thing about our approach is I have to spend a lot of time just, you know, finding the right resistor and then putting it in there. If these are labeled, I can just place it all there at once and then flip it to the back, solder them on, and then cut all the legs at once. But I'm just too lazy. All right, let's see. Oh, remember we want to cross stuff out as we go on the manual, so we know what we've done at a glance. All right, here's my pen. So what we've done is R1. Let's just cross that out over there. Okay. All right, I'm just going to measure these. Never mind, I'm going to measure this on camera. So if I made a mistake, you guys will know as well. What's this? 1 point, you guys can see that, huh? Was this 1.8 mega, which is R2. Oh, we're lucky. R1 after R2. Okay, R2. Where's R2 on this bad boy? Let's try to find it. Because since R1's here, R2's gotta be similar place. So it's this one, it looks like. Just want to double check, because sometimes you want to make sure the labels are the resistor labels are actually indicating that resistor, because sometimes, you know, it might be like up or down and you gotta make sure. But it looks like the labels are relatively close and it's all corresponded, because since this last one also has this one down here, so I'm pretty confident that this one is actually R2. Anyway, let's bend this thing, plug it in to R2. Okay, why don't we just do this? Okay, and then I'm gonna pick up another one and then find it. Okay, yeah, that actually works better. What is this? 228. This might be like 300 ohm. So R6. Then let's also get rid of that on the paper. R2, we got it down. 300 ohm R6. All right, let's find R6. I'm bending this thing. Let's find R6. R4 is here. R6 is here. Where's R5? Oh, R5 is here. 2, 3, 2, 3, 5. Oh, whoa, this is a tricky. The R4 is over here, but R5 is here. So 3 is here. 3, 5, 4, 6 is over there. All right, anyway. Let's take the next guy. Looks to be 1K. Or 1.1K in that case. So R9. Spin this thing. Where's R9? R8 is over here. My guess is along this row here. R9, right? No, R8. What's what we want? Wait, what? No, R9 is what we want. Whoopsie. So this dude here, just plop it down. Okay. What's next? Two mega R4. Oh, this is the tricky guy. R4. Oh, sometimes I would like to, you know, expand on the legs a little bit so it doesn't fall off. what was this? R4, right? R4 is over here. Just get the legs out a bit. Okay, make sure to cross that. R4. Okay. Next guy. 120 ohm. R8. Where is R8? R8 is over here. Plop it down. Okay, it's done. Let's get another guy. What is this? 300 ohm. Again, this is R14. Let's cross it out. R14. 15's over, whoops, 14's over here. Okay, all right, let's bend the legs outward a bit so it doesn't fall. Okay, next up. One 200K, 200K, R3. All right, R3. Let's cross this out. R3 is where? Here. Expand on the legs. Okay, cool. Next up. Looks like it's 300K. 300 ohm, R17. Oh, we just did R3, right? Did I cross that out? Yeah. R17, probably here. Oh, 17's over here. Okay. Where is it, the legs? All right, next up. Let's do something. Let's try, let's just bend all these legs. I'm so tired of bending them individually. I can even bend two at a time. Rest of these. Apparently there's no one watching right now. It makes me feel lonely. Oh well, someone will watch it, right? You're just in the future. So this is 20K. 20K, only one guy is 20K, which is R5. Plug it there. R5, okay. Next. What is this? 180? 180 R7. R7 is over here. I think this build is relatively easy. It's easier than I thought. Like when all the components are laid out, it's not that much component. I think it's like what, less than 50 or definitely less than 100, which is very minimum. What is this? 1.1 R10. I stopped crossing things out. I'm too lazy. R10's over here. Alright, cool. Get these legs. Alright. What's this? 180. 11. R11. Okay, let's fit that thing in there. I don't know which is which anymore. Which leg is for which one, but it doesn't matter. We're almost there. Putting all the resistors down. Oh, come on. 100K. 100K. R13. Here. Okay, next up. $200, right? 200. 200K. R15. 15's over here. Hold it down a bit like so. Touch on these legs a bit so it doesn't fall on the other side. Okay. What's this? 1.1 again. It's either I think it's R16. 16's over here. That's right. Alright, we have one more left. And then that one was sitting on the side. Let's measure this last guy. 120 ohm. So it's probably R12. Okay, yeah, I see where R12 is. It's over here. Alright. Now all these are plopped down. Can carefully flip it over. So since all the resistors are like over here and over here, let's put this away. What I'm gonna do is just to solder one row down first, and then we can flip it around, and then maybe, you know, adjust here if it's, you know, crooked or something. Let's just do a final inspection to check if every resistors are in place. The layouts are actually pretty easy because there's no resistor like suddenly over at this corner or something, so you know it's not hard to miss. I mean, it's hard to miss if I got something wrong. Alright, cool. So let's solder a row first down. It's getting kind of crowded here, but we can do it. Boom, 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 boom. Here, boom. Here, here, here. Alright, let's flip it over just to see if they're crooked or something. Maybe we can reflow it over here because these pads are these holes are so big. Okay, cool. Perfect. Now I'm gonna do the other side, this row over here. And then so we can do the final row all at once. Okay. Oh, didn't get that. Okay. Alright, let's see. I think all of them are soldered, right? Okay, not this guy. Let's see. So yep. So what I just did was this verse. Okay, here. Overflow time. Okay. These are good. These are good. This one's good. I'm just wiggling with my index finger. Okay. Okay. Awesome. Alright. Now what I'm gonna do is I'm going to pull out all of the other pins straight. So you know it looks good that way. You don't have to do this. It's just my OCD. This dude is being a pain. Okay. Alright. Install the rest of the rows. This is a really easy, relatively easy kit to solder. It's all through hole. There's no tricks or anything to get this thing to work. It's really beginner friendly, I would say. Maybe like next time when I stream, I can build a something with SMD, so it's more challenging and might be more interesting to the viewers. I recently ordered a mutable instrument stages. It's a modular synthesizer. It acts as an LFO. You can use it as a 6-step sequencer, I think. And then you can also use it as an envelope generator. And I mean, that thing is so versatile. You can do anything with it. So, and I'm missing I want an envelope generator really bad because I don't have one. And so I ordered it, the PCB. Looks like we got all the everything here. Okay, let's cut the legs. What I would do is I would actually like hold the legs I'm trying to cut because they tend to fly out sometimes. But you just need to be careful. It's actually kind of hard to solder stuff when you have a camera like right in your face, because therefore I can't get closer to the board, like I can physically get my head closer to the table. Oh, we're missing this one guy. No big deal. Alright. Well, someone's watching. What time is it? I have to take a rest at 9 p.m., which is like 15 minutes away. Just so you know. Let me inspect this a bit off the camera to see if everything looks nice. Yeah, looks so far so good. Looks good so far. I'm gonna reflow everything just a bit so it's nicer. It's not necessary, but I want to. The pads are actually pretty small. These are not like your everyday, like your Adafruit kit or SparkFun making thingies. Like the pads are not as big. Maybe this is not that beginner friendly. Maybe beginner to intermediate friendly, I would say. Okay. Alright, everything is reflowed. Nice. Alright, cool. All the resistors are done now. So what's next? Diode. There's only one diode. Where is my diode? Here. So the diode, you have to be careful about the polarity. Usually the black one, like the one with the black band, I'm not sure if you can see that, but the side with that one black one is negative. So it's D1. So sometimes the board will mark it for you, like it's over here, and see this band over here. So, you know, that's where the negative is, or where the band's supposed to go. So just directly like that. Easy peasy. Okay, looks nice. Okay, cut this thing. Alright, now. Oh, so this is called HF chokes. HF chokes. I guess it's like high frequency chokes. These are non-polarized, like it doesn't matter what polarity it is. So L1 and L2, so they go on here. We can see this length, the best length. Okay, that'll probably fit right. And these are the same. Yeah, they're all 100 microhenry. Try to bend this thing. Okay. So just these two. Alright. Awesome. I know they're crooked for sure because they're so loose. But after this, we'll flip it over. We'll reflow it like so. It's really hard to operate this solder when you have a camera like right in your face. The camera is like 1 inch away from my head, from my forehead. Good enough. Okay. So far so good. And look, we're almost done. What is this kit? Does this even work? It's so simple. Alright, what's next? Let's see what's on the table. Oh, the LED. I hate this blue LED for some reason. Can I change it for something else? I really hate this. This weird looks so weird. I never seen a blue LED like that before. Let me try to find if I have an extra green LED, which I think I have. Let's see. I don't know where they are, but I thought I bought like a bunch. Alright, you know what? Let's just leave the LED for now. I'll find one later. So the next thing, oh, so these are like variable capacitors, capacitor trimmers. Obviously they go here, and there's only two, so like C4 and C6. Oh, these are really loose, so let's do this. Let's do it one by one. Okay. You can like leave the iron on there, so the solder completely wraps around the pad and maybe a little bit on the other side, like that. Alright, second trimmer. Whoop, we got some excessive solder, it's no problem. You want to clean your tip almost every time you finish one joint, because the that extra solder you left on the tip, it's going to mess up your next solder joint. Let me inspect this a bit. So far so good. This is going really well. Alright, now, okay, so now it's these ceramic caps. Okay, so these are like, I forgot what these are called. These are electrolytic, so they have like chemicals in them. So you see like they have a white stripe on a certain side, that means it's negative. The instruction says to do ceramics first. So looks like we have multiple values of multiple. Oh, we have 5 of them. Each of them are all different. So let's see this guy. What's this? 1. It just says 1. 3. 1, 3. What's this? This is unlabeled. Oh, 104. So 104 means like 10 times 10 to the 4th picofarad, I think. What is this? 221. So this is 22 times 10 to the 1 picofarad. What is this? It's so tiny. 121. Okay, so on the instructions here, it says C1 is 0.1 micro. So I guess, okay, we can just use like elimination on this thing, because I forgot like how to exactly calculate this thing. I mean, I don't want to bring out a pen and pencil just to do that. 104, I guess this is 0.1 micro, so this is C1. What's this guy? 22. So the only one with 22 is 220 pico. So yeah, so 22 times 10 to the 1, that's 220 pico. So this is 1, 2, okay, and this is what? Okay, so if these are pico, then this, if it just says a 3, then it's 3 pico, 1 pico, and now we're the only one left. 12, 1, it says 121, so it's 12 times 10 to the 1 power. So that's 120 pico here. So this is C7. Alright, so let's do C1 first. Let's try to find C1 here. Where is C1? C1's over here. Since these are so tiny, I'm just gonna do it one by one. Okay. So like that. Looks good to me. Let's do this. The other leg. Okay. Perfect. Alright, so this is what C2. C2 is over here. Ooh, we got bad news because we have one solder that's filled up one of our C2 pins. That is fine. It is not the end of the world because it's relatively easy. Oh, it just filled up that hole. But what we can do, there's two ways to go about this. One, we can use this solder sucker thingy, which I think we can, and the other option is to use the wick, but I don't think the wick is gonna help in this situation because the wick is good for SMD mostly. Yep, I got it. C2, plop it down. Okay. I gotta be very careful when I flip to the other side because I don't want to bend on the legs too much. I mean, I don't want to like bend it like what we did on C1. But anyway, so C3 is this 3 pico. Come on, okay. These are so tiny. Speaking of tiny, so that mutable instrument thing I talked about, I think that specific module contains 0402 components, which is probably the smallest thing you could solder bare eyes. C5. I just did a module that contains 0402 and that was really fun. C5 is over here. C7, the last guy here. Alright, let's see. So I think I'm gonna take a break after I solder these two components and like after I cut the legs as well. And then come back maybe 30 minutes later and then finish this thing up and see if it actually works. How exciting. Okay, I'm pushing on the other side and just watch the legs stand up straight so it's not crooked. They're perfect. My head is usually closer to the board. This is really hard to work with. Maybe the camera can come in the other way. Alright, we've got them all down. Let's cut the thing. Cut the legs here. Oh, see, that went flat out just like that. You don't want that to fly in your eyes. Just cutting them. This is pretty easy task. Alright, let's see. Let me see this thing off camera. Alright, so far so good. Let's take a look. Well, yeah, let's take a look. So what we've done is we've got all the resistors down. We got the coils. I forgot what these are called. Oh, inductors. Yeah, inductors. We got the inductors down. The diode is down. These two trim capacitors are down. And these ceramics capacitors are down. I'm gonna change this LED. This blue is really weird. Anyway, next we wanna do... What do we have next? Oh, step 1 is here, step 2 is here. That's weird. So step 1, okay, so this is the analog board. I wish I'd read this more thoroughly. So this is the analog board, so I think maybe we're done. Oh, wait, but there's more stuff here. 6, 7, oh yeah, so next is like pin header, the electrolyte, the capacitor, switches, and then the pins. Attention, do not solder any parts onto the board if you find problem, otherwise warranty will be voided. Okay, obviously. These test rings, and then the jumpers. Okay. Main board, we only have what? Supply power, check display. Oh! We totally forgot to do this one. Alright, so it's just simply as just plugging in a USB power to that board. Alright, let's try that right now. I think I have a USB power lying around, okay. Indeed I do. Let's see. Alright, just plugging it here like that. On the other side. Oh, interesting. What does it say? My power is not that far, okay. Oh, I missed that. So it just says running. There's a test pin, right? Okay, so usually the scope will have some kind of test pin. So like it supplies a constant square wave, and you can just short them and to calibrate your scope or whatnot. Okay, it's not doing anything, but that might be due to because we don't have... I need to read these instructions, but yeah, I mean the thing works, right? It says waiting, running, maybe just waiting for a trigger or something. But whoa, that's cool. Yeah, so I guess let me try to see like what sound. Okay. We can try to see if we can flash that firmware to put another image or even remove that, because it looks really ugly, even though it's just for like a split second. Alright, I'll be back real quick in about a minute. I mean, not a minute, 30 minutes or so. So I guess this thing later on just goes on like that. Oh, that'd be cool. Yeah, that's pretty cool. Alright, I'll see you guys later.